the reason I ask you this question is a lot of students they feedback to me, they say logarithm and indices it's very hard. Then I say, have you memorized all the rules? Then when I ask them about the rules of logarithm and then the indices, right, the product rule, the division rule, and then the power that can bring down, they don't seem to know the rules very well. So if you don't know the rules very well, then of course you can't do the logarithm questions, right? Does it make sense? Does it make sense to you or not? Oh, okay, good. So same thing. If you are not if you are not familiar with the rules for property of circle, you can't do it. Okay, okay. So angles in the same segment is this. Okay, so let me just move this aside. So we talk about angle at center is 2 times angle at circumference. Not all angle at circumference, just that particular one, right? Okay, that particular one. So I teach you how to look at it already, right? Okay, so that's how you use that rule. So now angle in the same segment is this. So you get a circle, and then there is nothing to do with the angle at center now. I mean, yeah, there is nothing to do with the center now. So as long as you have this, so angle 1 equals to angle 2, and then angle 3 equals to angle 4. Okay, so this is the angles in the same segment rule that you can use to find to have this conclusion. Okay, same segment means I think you can tell, right? This is equal to this, then this is equal to this. And I think another thing you notice is all these angles, they are angles at the circumference. Yeah. Okay. Okay. So therefore I think you can do the this question C already. Okay, because because this is 90, right? Because I use the, so this is an angle in a semicircle lah. Okay, so besides the angle in the same segment, right, the other one I talk about at the beginning of the lesson is angle at angle in a semicircle. So basically you have a diameter, and then wherever you draw the line, you have a 90 degree here. This is called this rule is called the angles in a semicircle. Okay, like I say, the reason might be phrased differently in your school, but the idea is the same. Okay, okay. All right. So yeah. So if this is 90, right, then I think you can start to see that if this is 20, so this is 20, yeah. So can you see this is angle at circumference, and this is also this is. So I think when you do questions, it's better for you to use a highlighter. So what you can do with a highlighter, you just highlight this. Can you see that this 20, this is also 20? Because this is angle in the same segment. Am I right? Then if this is 20, the x is 70, right? Yeah. Okay. So you apply two rules here. Okay. Yeah. So you have applied two rules here. All right. Then what about the last one? So the last one, this is 50. Why? Because it's a z, alternate angle. Parallel lines, right? Then alternate angle. Then you apply the angle in the same segment now. So x is also equal to 50. Because this angle and this angle is the same. Because angle in the same segment. Because can you see this angle same segment? Okay. So therefore this is also 50. Because angle same segment. Okay. Oh, when I say angle in the same segment means this blue one is is equal to this blue one, okay? And then over here it happens to be both 50-50. Okay, it happens to be, but don't assume. So the blue is equal to the blue, the red is equal to the red, but in this case they are all equal. This is just a coincidence. This is just a coincidence. Okay, it's not always the case. It's not always the case. Okay, can. So in a way, right, if you look at the question A, actually y equals to 25. You know why? Because angle at the same segment. Yeah, you could have used angle at the same segment, then you can get this y25 easily. Okay, okay, can. And then for the part B, right, for part B, the x, so this is not angle at the same segment. Let me tell you why. A lot of students, wow, they make this common mistake. They say, hey, since this looks like that, then I think this is also angle at the same segment. That means they say, hey, this one is equal to this one. No, not true. Not true. You know why? This angle is not touching the circumference. So in order to use the angles in the same segment, 4 of them must touch the circumference. You understand? So therefore, this question B here, one angle is touching the angle at center. So angle at center in your brain, right, it should trigger the thought of angle at center equals to 2 times angle at circumference. And the angle at circumference is the particular one, not all. Okay? So you need to use that rule, not this angle in the same segment. You understand? Yeah, good. Yeah, D, part D. Yeah. Where's the 80 degree? For D. D for dog. Yeah. Okay, 80 means this is the 80 you're talking about. Okay, yeah. Oh, this, okay, this one is opposite angle. This one is the cross. So this is, I call this the X. Okay, so this is opposite angle, not same segment. Okay, same segment only happen. Okay, so basically same segment is, I'm talking about the 4 angles on the circumference, and this one is not the angle at circumference. This angle is not at the, I mean these 2 angles, they are not at the circumference, they are not at the center. Sometimes it happen to be the center, but they don't need to be at the center. So this, you use the opposite angle. You understand? So angles in the same segment only apply to angle at the circumference. Okay? If not, then you use other ways to solve it. Okay? Okay? So I think till now we have learned 3, I would say, angles in the same segment, and then angles in a semicircle, and then of course the angle at center is 2 times angle at the circumference. That particular one, not all. Okay, so far we have. So I think it's a good practice. Let me go to slide 9. Okay, so it's a good practice that you try to not prove, but you try to like give yourself a summary, like take note, like write this down on a notebook, so that next time you just refer to it and you know. So this is the diameter, right? Then any angle that you form in a semicircle is 90 degree. Okay, I'm talking about the one that touching this one, not the one touching the diameter. Okay, so this is called angles in a semicircle. Okay, so later I will come back to this. So this is the first rule you need to memorize. Okay, then of course the other one is center, then 2 times in the circumference. So this is the center, and by the way, this is the center also. I use the origin O to represent that. It need not to be the diameter, just to let you know. Which one? Rule one or the rule two I'm going to talk about. One has to be the center. I mean diameter ma. Diameter has to cut through the center. Okay, so if this is the angle at center, so this is angle 1, then this is your angle 2. Why? Because you look from this perspective. Triangle. Okay, oh, that one is no, that one is another one. I know which one you are referring to. Maybe I attempt to answer your question later on. So this is angle 1, which is the angle at center is 2 times the angle at circumference. Only this one, only angle 2, not angle 3. Angle 3 is not. I know angle 3 is also the angle at circumference, but it's not the one that has a 2 times relationship with the angle at center. Make sense? Okay, so only because you look from this perspective, okay, so therefore you kind of like look, you understand me? That's how you look at it, like which two angles actually has this relationship. Okay, then of course the 3 is the same segment. Angles are in the same segment. This one nothing to do with the center. So I just use a different color to color it, so you know. Okay, okay, okay. So I think just now, okay, let's go to slide 10. So you were talking about there is this I think you're talking about this one. This angle 3, right, is equal to angle 1 plus angle 2, but it's not 2 times. Is they add up. Okay. Yeah, I think you're talking about this one. Yeah. Okay. But they are not 2 times. Okay. Okay, good. Any more rules? Let me see. Like the one that you I think you show me a page, not of question, but of the rules. Which page is that? No. Did I delete that one? Yep, looks like I've deleted that one. No, just now you sent me a page of, yeah. I remember you sent it. Yeah. I remember you sent me I think some rules which I say, hey, this looks familiar to me. Like I ask you for some context. Yeah, that one, that image. Where's the image? Maybe I cleared that one already. But never mind. Okay, good. Okay, yeah. So can you try E? Okay. All right, then let's go to that. Let me see if I can. Okay, good. Yep. So slide 6 is here. So this is figure 1 is they talk about angle at center and then angle. Okay, so this is also angle at center. This one is angle at circumference. You look from this perspective. Hold on. 来，
这个充电器充进去，我想买一个，
对，你要买
我得上那个
啊，你下去逛一下就好了。
超市，
什么？
底下超市有那个多换灯吗？
对你自己走一圈你就知道了。
我得下去。
Okay, hold on. Let me just attend to. So 这边，特别是这边OK，你站在这里，你站在这里一点，因为你看到一个地方，站在这里就好了。有看到那个暗暗的那个字3个字吗？珍珠坊。 我们这边是唐人街，就是中国城啊，这边是中国城啊，所以那边你去那边逛一下，有很多中国吃的、中国卖这种转换头一定有。
不是，你是插来插不进去。
我知道，所以你要一个转换头。
哦，OK。
所以那里有转换头。
OK。
明白我意思吗？因为那边是我们这边是中国城，所以中国的什么东西，你可能找到一些中国小吃、中国的那个零食都有。
那我就是穿踏板能出去吗？
可以，随你随你。
那穿进来呢？还能穿进来吗？
那我建议你穿这个板子出去了。对了，这个就穿在家了。
对呀。
然后你的鞋就放在这边。
哪个鞋？
我的鞋都放在这边。
这踏板能穿进去吗？
什么？
踏板。
你的这个拖鞋是吗？拖鞋你就放在那个房间里。
OK。
明白我意思？
我就光脚出来穿鞋。
对对对，出来穿。
OK。
好不好？OK，谢谢。
我的钥匙找了。
找到吗？OK，可以。Okay, good. Yeah, I'm back. Okay, so this is another perspective you can look at that you get the angle at center, then 2 times the angle at circumference. Clear? Okay? So in a way, right, if you observe this angle at center is 2 times angle at circumference, right, is they have an angle at center, and then they have 3 angles at the circumference, but only one of them is 2 times. Same thing. This is the you just see it this way lah. Okay. So same thing. This is the angle at center. This is the angle at center, right? Then this is the angle at circumference, right? Then there is another angle at circumference. There another is angle at circumference. Okay, there are 3. So, but once again, only one of them is having the 2 times relationship. So you just look from this perspective in this case. Okay, then this one is from this perspective, right? Okay. Then this one is about the same segment. We have discussed that. Yeah. Okay, so we have discussed all the 3 rules. You have more rules to introduce to me? Okay, let's go to slide 10 is questions, not rules. Or more than. Oh, okay, so that means basically given the 3 rules on slide 9, then you should be able to do this question. Yep, you can attempt it, try it out. Because I start to see that you have this 25, they are out of the circle already. So I don't know whether there is one more rule that is relevant to this kind of scenario, like the angle is out of the circle. Because if you observe, right, you observe the 1, 2, 3, right, rule number 1, 2, 3 here on slide 9, right, they are all inside the circle, right? So the one, I mean this this one is also out of the circle already. Okay. So when they are out of the circle, I think you need to use I think there is one more rule that you need to there are a few more. Yep, something like that. Yep, something like that. Yeah. So you probably want to get it on the slide 10 so that we can discuss this rule in depth. How? 对了，我建议你慢点做慢点因为有个人他来第一天就手机都不见了。
手机。
对，就慢点，
丢了呗。
就是你自己做事慢一点。
OK。
我不是说外面人偷，就是你可能自己太慌啊，那锁匙又掉，等下手机又掉，就不好了。
OK。
好，慢点好。好。Okay, which one? Okay, the external angle that's cyclic. Okay, this one is very interesting. Hold on. So is okay. So can I ask you, is this one and this one they are the same thing? No. No. Okay, good. So what is this? External angle of a cyclic quadrilateral. Okay, quadrilateral means it's a four-sided lah. So it's here, 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 right? So, okay. Uh, okay. I want to introduce another rule to you. Let me go to slide 9. This reminds me. So it's a rule 4. So rule 4 is, so far I'm talking about angles in the circle. Okay, they are not out of the circle yet. Okay, so you have a quadrilateral inside. Okay, any quadrilateral. This angle 1 and angle 2, they add up to 180. This is this rule is called okay, maybe I should write it below. This is called angles in opposite segment. So angle 1 plus angle 2 is 180. Then of course, if this is angle 3 and then this is angle 4, so your angle 3 plus angle 4 is 180. Clear? Yeah, okay. But okay, hold on. Let me be very clear with you. Angle 4 plus angle 2 is not necessarily equals to 180. No. Okay. Always read the reason. It's opposite segment, opposite to each other. Okay. Unless this is parallel, but I never say it's parallel. Okay, so you cannot assume that. Oh yeah. So if it's parallel, it's interior angle. You're right. Yes. Okay. Okay. So now I look at your this rule property 5 here, right? So your property 5 here, it says what? It says this external of a cyclic, which is x, right? Is equal to the is x equal to b in this case? Do you know why? Basically, they are using my rule. I mean, maybe it's not my rule because, okay. Basically, they are using this rule because can you see that if you extend this out, your this angle 3, because angle 2 plus, okay, angle 3 plus angle 2 give you 180 angles on a straight line, right? Can you see here? So can you see that? That's why angle 3 and angle 1 is the same. Okay, so in a way, you don't have to remember that the what external angle cyclic. You don't need to memorize this. You don't need to memorize this. All you need is slide 9, this one, 4. Does it make sense? Yeah. Yep. Yes, you're right. Once again, circumference. Yes. Circumference. So in a way, right? So this one, rule 3 is about angles at the circumference. Okay? It applies to angles at the circumference. So this rule 4 is the same thing. Angles at the circumference. All of them. Okay? But for the 1 and 2, right, they have something to do with the angle at center. Yeah, angle at center. Yeah, and this is also angle at center. In a way. That means something to do with the center. So what I'm trying to tell you is that's how you can kind of like categorize this 1 and 2 as they have something to do with the center of the circle. Okay, and then for the 3 and 4, they have nothing to do with the center. Everything is to do with the circumference. Okay, you understand? Okay, so that is how probably because sometimes, right, if you look at a circle, right, it can be quite confusing which rule you use because there are too many rules. That's the reason why at the start of the lesson I asked you for some context. Yeah, you can't just search in your universe, right? Like in your maths universe, is is so vast. Okay, so you have to somehow have a direction. So in a way, right, rule 1 and 2 something to do with center, rule 3 and 4 something to do with circumference, so you have a direction. Okay, should I choose the rules are related to the center, or should I choose the rules related to the circumference? Okay, so this gives you a direction. Okay, so this property 5 we don't have to remember it because yeah, it's our rule number 4. Then alternate segment theorem, I think this one is very interesting. Okay, this one is very interesting. uh, this is, if I'm not wrong, this angle, right, this angle here, I think is equal to this angle, but how come your book never say anything? Wow, you know, did, can, yeah, can you tell them we are learning math, we're not learning English? Okay, okay, never mind. So let me just go and search for tangent chord theorem, then just get it. Okay. Pythagoras theorem. Okay, what's the meaning of theorem? You know, for me, I just memorize it. You know, I don't care whether it's a theorem or theory or Newton's law. Why you never question Newton's theorem? Why it must be Newton's first law, second law? Why not theorem? Why Pythagoras theorem? Why not Pythagoras law? I don't want to dwell too much on the English. Okay, right. But it's a good question. I like it. Okay, good that you raised some funny question. Okay, let's go to slide 11. So I'm going to upload this page, tangent chord theorem, which is not given by your book. Okay, so this is a very visual representation of that. Okay, so how to look at it. Okay, so this is the red one, so the red and red is the same lah. So blue and blue is the same. Okay, so if you think of this is angle 1. Okay, let me choose different color. Choose this. If you see this as an angle 1, okay, so this is your angle 2. Okay, then this is your angle 3. Okay, so your angle 1, then this is your angle 2. So you try to go clockwise. Okay, you try to go clockwise. So definitely angle 2 is not equals to angle 1. I think you can tell, right? Yeah, definitely it's not equal. Okay, then you just go clockwise. So angle 2 is not, so the first angle is not equal to your angle 1. I mean, go clockwise. Okay, go clockwise. The first angle here is not equal to, so the second one it is. Okay, okay, so the second angle, okay, clockwise, CW, clockwise, is equal to your angle 1. So same thing, angle 3, so angle 3 you must look anti-clockwise. Must look anti-clockwise because you have to go that side already, right? So definitely angle 2 is not equal to angle 3, right? Then you go anti-clockwise, the second one is equal. Okay, this is the second one if you go anti-clockwise. Okay, so similarly, let's go back to your slide, this property 6. So if you are asked to find this angle, right, so I use the same strategy. So I know that this angle is, okay, so I label this angle 1, I label this angle 2. So angle 2 is definitely not equal to angle 1. Does it make sense? Then I need to, okay, so this is anti-clockwise, right? So anti-clockwise, the first angle is this one. This is the first angle, right? So the first angle is not equal to angle 1. The second one is, so this is one, this one is. So angle 1 equals to angle C. Okay? So it works the same if you go, okay, so are you talking about the if you are looking at BDA? Yep, yes, yeah, yes. So maybe we try the clockwise one. Now we try the clockwise. Okay, so I think it's good that you use a highlighter. Like that's why I say it's good to use a highlighter. So you use a highlighter, right? Is this? We are looking at this triangle. Okay, so maybe you are talking about this angle now. Let's try to look at, so this is angle 1, and we know that this angle 2 is definitely not equal already, right? So this first angle is definitely not equal also. So it has to be the second angle because clockwise, right? This is the first, this is the second. So angle D equals to angle 1 in this case. Does it make sense? Yep, good. So that's how you remember this called tangent chord theorem. Okay? Good. So that is our rule 5. So let me just get it here. Okay, here. So this is angle 1, right? So let's look at the anti-clockwise. So this is the first angle, and then this is the second angle. So the second angle is equal to the 1, right? Okay? Okay, so this is our rule number 5, tangent chord theorem. Okay? So yeah, so with this, I think you can try to attempt the EFGH already. Or you still have other rules? Oh, okay, good, nice. Okay, yeah, good. Yep, attempt the FGH. This is angle on a y is equal to 180. Okay, yeah, isosceles. Yes, so this is very common. So you always identify the radius. How? This one is same segment. Angle at center. Yeah, over here. Yeah, so you look from here, right? So you look from this, perspective, right? Yeah. Yeah, so sometimes, right, when you do these properties of superposition, you have the physical paper, you need to turn it to see it, All right? Yeah. Y is equal to X, Y. Segment, correct. So you just make sure that your school use the same reasoning. Oh, yeah. By the way, this is 90. Yeah. So basically, that's the reason why yeah. So that's the reason why I say it's important that you use a highlighter. So I know it gets very, very confusing, okay, sometimes. So you have to really like use a highlighter or use pencil to label the angles. So use whatever method that can help you, okay? Mm. But Z is the small one. Mm. So this is 29. This is also 29. You have a parallel. You have a parallel. So this is equals to X because it's parallel. So you have this alternate angle, right? Then that's how you figure out the Z. This is 29. Okay. Okay, good. F. By the way, this angle is not at the circumference already, so you cannot use. I mean, you need to use another strategy. Yeah. This angle is also not at the circumference already, so you cannot use. This angle also not at the circumference. I think there is one more rule. Later, when you do G, I will introduce to you. You do the F first. Okay, label it. Label it. Yes. Continue. Yeah. Good. Good that you saw that. So this one. Then you can find out this already. Then you can find out this already. So that's the reason why I really recommend students to use a highlighter, so you can highlight the thing that it means the figure is very, very complicated. Okay, it's it's a it's a combination of lines. Okay, so they try to confuse you so much, so you need to focus. So by highlighting that figure out that you want to focus on, it helps. Okay. Yeah. Yes. Yeah. Okay. Good. Yep. Stop. Okay. So in fact, I think G is a very good question. That okay. G is the last question that I'm going to introduce the last rule. Okay. So let's go back to slide 9. Okay. Slide 9 here. Let me try to squeeze in the rule 6 here. So this is a summary page for all the rules. So I think it's good that you note down all these rules also. Okay. Later on. So 6 is if you have a circle. and then if this is the center, and then this is the radius, so this is called tangent to the circle. Okay, so tangent to the circle, or tangent to the radius, right, will form a 90 degree. Yeah, that's it. That's it. Okay, so therefore, if you apply this rule to this one, so this is a okay. I, oh, that one. Okay, this one I'm going to so-called prove to you. You don't have to memorize. You don't have to memorize. Okay, good. So maybe I just do the question G together with you. So then you don't have to prove. You don't have to memorize the other one. Okay. So this is 90 degree because this is this one is the tangent. Okay, this is tangent 1, T1. I think this is another tangent. This is your T2. So tangent to the radius is 90 degree, right? Okay, so this is your radius, this is your radius, this is your radius, this is also your radius, right? Okay, then this is your common side, right? So this is your common side. So therefore, radius, common side, radius, common side, this has to be equal, you know. Because you use the Pythagoras theorem, they end up with the same answer. Yeah, so therefore you don't have to memorize that. This, let me use the blue card. This one is equal. I mean, you don't have to use that rule. You can use the Pythagoras theorem to prove it. You understand my point? So these two are equal. Okay. Okay, good. So with this, so therefore this, by the way, that means this figure 1 and this figure 2, they are congruent because side, SSS. So you can prove that they are congruent. So if they are congruent, your x, actually this is also x. Right? Okay. Okay, I leave it to you. Never mind. So basically this is angle at center is 2 times angle at circumference. You look from this perspective. Okay? So it should be 110 times 2, right? So 110, you need to divide by half. I mean, you need half 110 because they are the same, because congruent, right? So this is 55. So this has to be 55. So therefore your x is 35. Okay, that's it. Make sense? So I think we have yep. So I think there are 6 major rules for properties of circle you need to memorize. Okay, so let's try H on your own. For this question, there is no tangent. There is no tangent. Just to let you know, there is no tangent to the circle. This one is not the tangent. This one not the tangent. Just to let you know. So generally what I do is good. This is 45, right? Generally what I do is I will use this shading, highlighting to help me. When I do on a physical paper. Of course, I use pencil because in any case I need to erase them. I can easily erase them. Alright. And once again, this is the 90, if you can tell. Yeah, like I think you need to get used to the angle in a semicircle. This is a diameter. So yeah. So next time when you have a diameter, then you can quickly just use a highlighter to quickly highlight the diameter, and then diameter usually give you what angle in a semicircle, 90 degree. Okay, so seems like you are you can't think of this yet. Yeah. Mm. Mm. Yeah. I think you can get this one also leh, because they add up to 90. This blue one. Yeah. It's 45, right? Okay, good. Yeah. Continue. Mm. Why 20? Mm. Nice. Yes. Yes. Yep. Yep. Good. Yep. Good. Yes. Good. Yes. Good. Nice. Yep. Correct. Absolutely correct. Yep. Absolutely correct. Okay. Okay. Good. Yeah. So yeah, I think as long as you memorize the these 6 rules, 1, 2, 3, 4, 5, and 6. So as long as you can memorize these 6 rules, I think you should be in you should be good to solve all properties of circle question. All right, and you were talking about you learn another topic besides properties of circle. Okay, maybe you can give me some context by let's go to slide 12. Then maybe we can have a brief discussion. Then tomorrow we just explore this plane geometry in depth. Oh, you don't have notes. Okay, never mind. Then we just do one more properties of circle question, and then we can actually conclude the day. So you were saying you just came back home or something? You had, oh, okay. You had a previous lesson at home or over Zoom? Over Zoom. Oh, okay, okay, okay. Science? Oh, okay, okay. Then can you test your English teacher? Hey, I have this mathematics question. It's in English. Can you sketch the diagram out? If she he or she. Okay, if he can, that means his English is there. If he cannot, that means English is not there. Oh yeah, yes, I know. Slide 12. Yeah. Or maybe your English teacher is just one dimensional. I only know English. I don't know about mathematics. Yeah. Mm. Oh, okay. 2 circles. Okay, good. Okay, yeah. Go ahead. So when I get this question, right, the first thing I do is I try to use a different color to color the two different circles. Okay. Okay. Mm. Mm. So the plane geometry questions or notes, right? You can get them ready tomorrow for tomorrow's lesson. Oh, okay, okay. Oh, okay, then never mind. Then we can explore. We can explore more properties of circle question, or maybe some A math question as well. I mean the what do you call that? You don't call that A math, right? You just call them just math. Okay, yeah. Oh, okay, good. So yeah, so we'll talk about some other like the equation of circle. Remember that we talked about it the other time. Yeah. So so tomorrow our lesson plan will be properties of circle questions plus some other topics. Okay. Mm. Can you start something? Mm. I think you can start with the angles on a straight line first. The 180 minus 110 will give you 70. That is the easiest. Yeah. Yeah. And by the way, when the okay, never mind. Go ahead. I see a center. I see a center for the blue circle. So maybe you can try to use the angle center. Yeah. Yes. Yes. Yep. Yes. Okay. Mm. 140. I think you can find out already. Angles on the opposite segment. You know what I'm talking about? They add to 180. This one, right? Right? So x equal to 40. Because x plus 140 has to be 180. Opposite segment. Yeah. Right? That's it. Part 1. Part 1. So that means I'm expecting part 2. Yeah lah. Oh, okay. So it means I'm expecting what? Oh, hey. Oh, okay. HIJK. Okay. 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 So I think uh I hope um until question I you start to realize the importance of the this slide 9, these 6 rules. Why? Because just like I mentioned earlier, if you want to do trigonometry questions, you want to do logarithm question, if you don't know the rules, you can't do the trigonometry or logarithm questions at all. Oh, or you are like kind of like handicapped. Okay. So same thing. If you want to do well for properties of circle question, you have to be really well versed in these 6 rules. Okay, and I think this is a very good summary. Why I say so? 3 and 4, like I already categorized this 3 and 4 for you already, is something to do with the circumference. Okay, so if you see that you have angles, okay, 4 angles. If you see 4 angles on the circumference, then you think of 3 and 4. Okay, and if you have angle at center, then you think of 1 and 2, right? Then of course this 6, I will say tangent to the radius is 90. I will say 6 is a giveaway. It's like you should know it. 6 is like you should know it. Okay, It doesn't take a lot of brain power to remember it. Okay, then for 5, we just discuss 5, how we can see, right, the first angle, either anti-clockwise or clockwise. The first angle is not equal, but the second one it is, right? Yeah, so that's it. So you have the, if you look at the circle, if you have center, you think of 1 and 2. If you have circumference, you think of 3 and 4. And then 5 and 6, they are like they are the special cases. And by the way, 6 shouldn't be here also, because 6 is just, you should know it, right? Okay, so 5 is the tangent chord theorem. So this page pretty much sums up what we have learned today and what you need to know before you can do the properties of circle question. All right, so any other question for me? Okay, if not, then like I say, tomorrow's, okay, so I asked you, okay, let me just give you some material for our lesson plan tomorrow, so you can prepare for it. So take a look at our assignment. I think you know the link, right, to the assignment? Okay, so the latest assignment, I have ticked some questions. So those questions, we talked about it in our last lesson. Okay, please do those questions. I think I have ticked, like, I don't know, like okay, I cannot remember the number of questions I've ticked, but focus on the equation of circle. Okay, equation of circle question, and then focus on the kinematic. Okay, focus on the kinematic, and then what we talked about the other time, equation of circle, kinematic, and then what else? Very good. So binomial expansion. Thank you so much. Okay, so basically, if I've ticked more than 3 questions, okay, focus on these 3. So tomorrow we will talk about these 3 first. Of course, if you can finish all of them, the questions that I tick, go ahead. If not, focus on these 3. Okay, then on top of this, then we will talk about the properties of circle questions in more details. All right. Okay, you have more practice questions for properties of circle, right? I guess. So can I just ask you to go back and just get ready the materials, or you can practice a few, like several, like three of them, the harder ones. Not the, okay, just now the ones that you over here, like what, A to I, right? They are too simple. Okay, they're too simple. It's just for you to warm up your brain. So attempt some questions that are harder. Then tomorrow's lesson plan will be this 1 and 2. Okay. All right. So if there's no question, then okay. So just okay. So one more time. So please get online over Zoom 5 to 10 minutes earlier, so that we can quickly switch to this Google Meet. All right. So for today, I think it's a special case because I had a guest just now, so I excused myself for some time. So sorry for that. So I make sure that next time I will not entertain any guests. Yeah, I try my best. Okay, but things happen. Things happen. Okay, so just for today, sorry about that. Okay, so see you tomorrow. Good. Bye bye. Take care.